In this video, we're going to look at something called partition of a directed line segment. A directed line segment is a line segment that has a beginning and an end. So the first letter in the line segment means the beginning. And partition means separate. So the question we're addressing today is how to find the point P on directed line segment AB that partitions or separates the segment by a ratio of 3 to 2. And you can see the coordinates for A and B. So to accomplish this, we're going to map out the line segment AB and find out where the coordinate P should go. Then we're going to look at the coordinates and find the vertical change, the horizontal change, and the jumps. You'll figure out what those mean in a minute, that we will use to fill in the coordinates along the line segment that lead us to the point B. So the first thing I'm going to do is I'm going to lay out my line segment with A at the beginning and B at the end. And I'm going to write down the coordinates for A and B. These are parentheses for the coordinates. A at -2, 4, and B at 8, 19. Now, in order for me to break up this long line segment into a 3 to 2 ratio, I need it to be broken up into 5 little line segments. So I'm going to draw those in. This is just a sketch. 1, 2, 3, 4, 5. 5 little line segments for the 3 to 2 ratio. Now I can fill in the points that will connect these little line segments into the long one. Now I see that I want the part from A to P, the partition, to have 3 line segments. And then after the partition should be 2 line segments. So from A to the partition, 3. 1, 2, 3, and stop right there. And then you see after the partition, 1, 2. So I have my 3 to 2 ratio. So that means that the point P should go here. Now I got to figure out what is this point. So I'm going to add parentheses for my other points. Now we're going to figure out how to fill them in. Now I need to look at the vertical change and the horizontal change. So I have x1, y1, x2, y2. And remember, my vertical change is how far up or down. So this is y2 minus y1 equals 19 minus 4 equals 15. My vertical change is positive 15. My horizontal change, x2 minus x1, because I'm figuring out how far left or right. This is 8 minus -2 equals positive 10. So now I know positive 15 and positive 10. That means that my y values increase by 15 as I go along, which makes sense because from 4 to 19 is a change of 15. So I'm figuring out how can I count, how can I jump the same amount each time so that I leave from 4 and then land on 19. So now what I need to do is think about how many jumps I'm going to make. So I make, for 5 segments, I make 5 jumps. 1, 2, 3, 4, and 5 is the finish. So what I do here is I divide by the number of segments. There are 5 segments, so I'm going to divide by 5. What am I going to divide by 5? My horizontal change of 10 and my vertical change of 15. So positive 10 divided by 5 is positive 2. Positive 15 divided by 5 is positive 3. That means that my x values need to increase by 2 and my y values need to increase by 3. So I'm going to start at 4 and then I'm going to add 3. 4 plus 3 is 7. 7 plus 3 is 10. 10 plus 3 is 13. 13 plus 3 is 16. And if I did that right, 16 plus 3 is 19. Now we'll do the same thing with the x value. So we have negative 2 plus 2 is 0. Plus 2 is 2. Plus 2 is 4. Plus 2 is 6. And did we do it right? 6 plus 2 is 8. Yes, we did it right. So now we've filled in all of the coordinates along directed line segment AB. And at the beginning, we established where point P would be to give us a 3 to 2 ratio right here, which means that our answer is this coordinate, x equal 4, y equal 13.